Good afternoon, students. Today we are going to discuss the derivation of quadratic formula. Quadratic formula is very helpful and useful in solving some of the quadratic equations where we don't get the factors or the numbers are big and it's difficult to find the factors. Then we can directly use quadratic formula to solve those quadratic equations. The general form of quadratic equation is ax square plus bx plus c equal to 0, that is degree 2, degree 1, degree 0. And here the condition of course is a not equal to 0. A not equal to 0 because if a becomes 0 then it doesn't remain a quadratic equation. Therefore we must have a not equal to 0. B and c can be anything, they can be 0 also. Now I want to work on completing the square. Completing the square means I want say p plus q whole square or p minus q whole square. I want this expression as a complete square. So what I will do, first I will remove a because p square, we want square of the first term, x square we have, we don't want this a. So the best way to remove a is divide each term by a. So x square plus b by a x plus c by a. 0 by a is again 0. Now square of the first term plus, you know the expansion of this is p square plus 2pq plus q square, right? So I want, if it is plus and if it is minus then minus. I want 2 times this term. So what I will do, I will multiply by 2 and divide by 2 x. So if I go back, I will get back this, right? 2 multiplied and 2 divided plus. Now square of the first term plus 2 times first term into second term. So we want square of the second term, b by 2a whole square. This is our second term. Now plus c by a as it is, this term, and this b by 2a whole square added on RHS also, because when you add something on LHS, you must add on RHS also to maintain equality. Now you see this is a complete square, p square plus 2pq plus q square. So that is x plus b by 2a whole square. That's b square by 4a square. And this c by a I am shifting in minus. Now 4a square and 4a, LCM is 4a square. So this will be b square minus, this is into 4a, so minus 4ac. Right? Now if I go back to this, that means I have x plus b by 2a whole square as b square minus 4ac upon 4a square. Right? Square is that. That means x plus b by 2a would be root of b square minus 4ac upon. Now root of 4a square can be 2a or it can be minus 2a. So what I do, I put plus minus here because root of 4a square is plus 2a or minus 2a. Now that gives me two solutions, quadratic degree 2, it will have two roots. So x equal to, this goes on the other side in subtraction. So minus b by 2a plus minus root of b square minus 4ac upon 2a. Now denominator is 2a, it is a common denominator. So 2a minus b plus root of b square minus 4ac is one of the root. The second root is b minus root of b square minus 4ac upon 2a. That is, the quadratic equation will have two roots, b minus b plus root of b square minus 4ac upon 2a and minus b minus root of b square minus 4ac upon 2a. It has two distinct roots, but it's not necessary that every time time the roots would be distinct. Now, that is the derivation of quadratic formula. Now, let's work on what are the implications or further results based on this formula, quadratic formula. So, I am continuing with this discussion. Say, one of the root we show as alpha, which is minus b plus root of b square minus 4ac upon 2a, and the other root I show as beta, which is minus b minus root of b square minus 4ac upon 2a. These are the two roots, alpha and beta we show the roots as. Understand one thing, when you have terms under the root, you cannot have negative numbers under the root because then they are not real numbers, right? So what condition we have is this b square minus 4ac is called as discriminant. It's called as discriminant and we denote it as d. This is again controlling authority. If this d is less than 0, that means b square minus 4ac is less than 0, that will show that equation has no real roots. Why no real roots? Because discriminant is less than 0. Discriminant is under the root. Under the root negative numbers, that means no real roots. And if d is greater than or equal to 0, the equation will have roots. Right? Now, suppose d is equal to 0. Now, d is greater than or equal to 0, I have combined in one situation. Suppose d is equal to 0. Right? D is equal to 0, that means this term is 0. And this is also 0. That means alpha is minus b by 2a. Beta also minus b by 2a. That means two equal roots. Did you understand? So what I am saying, d is equal to 0. D equal to 0. That means this is 0. So alpha is minus b by 2a. D is 0. That means this is 0. So beta is also minus b by 2a. That means alpha and beta are equal. So two equal roots. Now if d is greater than 0, it will have two distinct roots. Distinct means different. Two separate roots but real roots. When will it not have real roots? When d is less than 0. That is, this term which is under the root b square minus 4ac is the controlling authority. It dictates the nature of roots for a quadratic equation. And if that is 0, then it will have two equal roots. If it is less than 0, it will have no roots. And if it's greater than 0, it has two distinct roots. Now, coming back to this alpha and beta, if I see alpha and beta and I add both, that is, I go for sum of the roots. So, if I add alpha and beta, you know denominators are same, we can directly add the numerator. So, this term will get cancelled. Minus b plus minus b, minus 2b by 2a, and that's minus b by a. That is, sum of the roots in a quadratic equation is minus b by a. Now, understand, b is coefficient of x and a is coefficient of x square. Now that is sum of the roots. If I go for product of the roots, so these are two very important relationships of the roots in a quadratic equation. So product of roots, again I can multiply numerator minus b plus root of b square minus 4ac into the numerator of this minus b minus root of b square minus 4ac upon 2a into 2a is 4a square. Now this is x plus y, x minus y. So x square, that is minus b square, minus y square. So b square minus 4ac, root will go off. A plus b into a minus b, a square minus b square upon 4a square. Now if I square this, minus b square would be plus b square, minus b square, this minus and minus plus 4ac upon 4a square. So now 4a cancel, this gives you c by a. That is the second relationship which we have got is alpha into beta is c by a. You have lot many questions based on nature of roots of quadratic equations, and of course sum of the roots and product of the roots of a quadratic equation. Sum of the roots of a quadratic equation is b minus b by a and product of the roots is c by a. Using that, we can also, suppose we know the roots of the quadratic equation, then we can frame the quadratic equation. If I look at this, this is nothing but x square plus b by a x plus c by a equal to 0. You know we got this when we divided by a. Now b by a is negative of this. So x square minus alpha plus beta x, that is if you know the roots of the equation, you can frame the equation. We are going two ways. We know the equation, we find roots. Now if we know the roots, we can find the equation. That is, it's two ways solving done. C by a is alpha into beta equal to 0. That means the quadratic equation will be x square minus sum of the roots. Yes, x plus product of the roots, that's equal to 0. That helps you in solving the finding the quadratic equation when roots are given. That's all theory about the quadratic equations, finding the roots, completing the square and relationship between the roots and the coefficients, and framing the equation when you know the roots. Work on it. Thank you.